So now let's explore how to leverage GIS in monitoring or analyzing the student risks to natural hazards. Just to revisit, in a nutshell, GIS is an arsenal of tools that we can use to analyze and visualize um, geographic information. In the online learning context, we can use this to actually get actionable insights of our students and their risks. Now, having these actionable insights, it enables us teachers to build custom materials and select appropriate modalities to actually maximize the learning experience of the students, again, in consideration of their risks. So what we're seeing right now is more of a closed loop learning. So for this session, let's look at the potential role of GIS into three lenses. The first one is more on the understanding the use cases. What are the possible questions that we can ask, research questions, what analysis that we can do. Next is more on the workflow, understanding how can we perform these types of analysis, these use cases. And then last is understanding or identifying the tools that we can use to perform these types of analysis. So for the use case, there are a lot of different use cases that we can perform, some of which are more on monitoring, understanding the student landscape and their risks, as we've seen earlier. Next is we can also perform deeper analysis. For example, understanding the trends, the associations of different factors affecting the online learners, performance, and whatnot. And then we can also perform scenario building with GIS. So this is basically the what if analysis. So for example, what if I use this learning modality? What would be the effect in terms of the resiliency of the students and whatnot? Okay. Zooming in with the use cases for monitoring. Again, there are a lot of questions. These are some examples. So for the basic ones, understanding where students residing, which locations in the Philippines are vulnerable to the different risks, and another question is: are the majority of our students in risk of the environmental, infrastructure, and socioeconomic factors? This is the student distribution of the UPOU during the academic years 2016 to 2020. You can see that there are dots, and these represent the different provinces, and the color gradations represent the um, population in their respective provinces. Again, we can see that densely populated provinces are in Manila, Laguna, Batangas, Pangasinan, and so on. We can also map different hazards. Here we can see the risks to typhoons, other geotechnical and hydrological factors. And we're not limited to environmental risks. We can also map different parameters like socioeconomic status, the integrity of or reliability of power system infrastructure, and internet connectivity. So viewing or looking at the different maps of those parameters I've mentioned might not that be insightful. So these different data sources can be overlaid to further get insights. So one example is combining the student risk, student distribution, and the storm damages from 2016 to 2018. So what we are looking at right now is the UPOU student distribution versus the damages from storms from 2016 to 2018. We can see the ones who are most vulnerable. Again, it's in Metro Manila and Laguna area. And having these types of insights, we can use this again to create interventions, proper interventions to make the learning experience of the students more robust to these types of hazards. Now, looking into more advanced types of analysis, sometimes we require analytical tools. So the research questions that we may ask for advanced analysis is, where is the student distribution increasing or decreasing for the past 10 years? How did the infrastructure improved over the past 10 years? So these are the types of trend analysis, analysis of trends. So we can actually perform this with GIS. Um, Again, we can perform scenario building and associations analysis. For the association analysis, we can actually understand what are the factors affecting our response, for example. Just one example, the resiliency of the students. What are the major factors that are significant in terms of their resiliency? So we can actually understand that through GIS. So one example of trend analysis is hotspot analysis. So these are two examples from the different a different domain. So I guess we can focus on the right one. So what we are seeing on the right one is the analysis or hotspot analysis using space-time cubes in COVID-19 analysis. So with GIS, we can understand the trend of spread of COVID-19, and they leveraged a tool, which is space-time cubes, to actually possibly forecast the spread of the disease. So actually, we can use this to, in our context, again, one example is understanding the increasing trend of our students distributed in the Philippines. Next slide, please. So we've seen the use cases. Now let's understand how to actually a high level understanding of how to perform these. So sometimes we have these different data sources that we can actually just directly visualize them using GIS. By visualizing, we can save them in a PDF form or PNG form and then submit them to the end users. However, majority of the times, there are irrelevant data from the raw data sources. We need to transform, we need to just select appropriate information um, and clean the data. And I guess this is one of the most important part of the process. It's data engineering. Again, more of collecting, cleaning, and transforming the data to get more relevant information. So with that, again, we can visualize them through yeah, through different GIS tools. Now, moving forward with more advanced analytics, we can actually use spatial analytics tools. So one of which is the space-time cube I've shown earlier. So with spatial analytical tools, we can derive further insights. And I would just like to note that there's an arrow from the spatial analysis block to the data engineering because this is an iterative process. This is not a waterfall process where you need to collect data, perform data engineering, and spatial analysis. So after that, again, we can also visualize it. Sometimes we want to deliver our products to the end users. So if you're familiar with dashboards, you can actually access data maps using the internet. And we utilize geoportals for this. So this is more of an IT or cyber GIS infrastructure that we need to establish. Next slide, please. So this is an example of a dashboard. It's from NOAA. So you can actually interact with the map, download, and some of the geoportals available, you can also upload. So there are geoportals that you can actually upload information like a crowdsourcing platform. The next slide, please. Now, what are the data sources that and tools that we can leverage? So for the data sources, internet already has a ton of data. So most of them are open access. So some examples are from PSA, humanitarian data exchange, and whatnot. But I would just like to highlight the freedom of information. So you can actually request government agent data from government agencies. You just have to post on their platform. Also, I would just like to highlight the social media platforms like Meta and Twitter. So they also provide relevant information, like what you've seen earlier, the socioeconomic status. That's just a relative index for the socioeconomic status, and it was downloaded from Meta. So you just have to search the web. And for the tools, most of the tools may enable us to perform data engineering, visualization, and spatial analysis. To the right, we have ArcGIS, QGIS, and Carto. On the apologies, on the left. On the right, we have Python, R programming, and Google Earth Engine. This is not an exhaustive list, but these are the popular tools. The difference here is that the ones on the right, or the ones on the left rather, are relatively easier to use. They're more user friendly, and on the ones on the right are more complex. Now, you can actually use a combination of them. So why do we need to use those programming languages on the right? So there are instances where the data is really complex and there's no custom tools from ArcGIS and QGIS. So we can also leverage these programming languages to actually solve complex problems. I guess that's the last slide. Basically, in terms of the potential of or the utilization of GIS, it's not just about the tools and whatnot. I guess it's more of first identifying the right research questions. Next is identifying the right workflow, because we sometimes we don't need to do geoportals or build geoportals and whatnot. We just need to spec out or specify the right workflow. And then last is using the right tools. We don't need to code everything. Sometimes there are problems that we can use more basic or user-friendly platforms like ArcGIS. That ends my presentation.